Okay, so we're back, and we've got a slightly different camera angle because I have to be plugged in now. So, so what we had just done, if you recall, is that we had calculated this z-score, and it was 0.065. So what I want to do now is I want to talk about how we're actually going to use that in order to calculate this area, which, if you recall, is going to answer the question for us of what the percentage of scores above 73 is. Okay, so that's a summary of what we were doing before. So we're going to go to the table, and if you remember, the table, that row that we looked at before, said that 48.43% of the scores should be in this area here. So that's telling me that's 48.43%. Okay, now that doesn't answer the question of what's this area to the right-hand tail there that we're actually looking for. But the symmetry of the normal curve and the symmetry of this region help us out, because since it's symmetric, that means there's the same area here and here. So what that means is we're looking for some number that when I add it to when I double it and add it to 48.43, I get 100%. In other words, to put it in a more simple way maybe, if I take away the 48.43 from 100 and divide that by 2, I'll get this. So let's do that. So you got 100% minus 48.43. So that's going to give me 51.67. So that's the percentage that's outside of the area. 100 minus what's in the area. And now if I divide that by 2, so 51.67 divided by 2 is 25.835. You know, that's a lot of decimal points. We're probably really just interested in the fact that it's about either, you could say, 25.8% or maybe even just 26%. I'd say for this problem, since, you know, everything seems to be given, like that number seems to be given only to two significant figures, and same with those, I'd say probably your 26% is about as accurate as you want to be. So 26% is what we'll say. So that's the answer to the question, is about 26% of the scores should be above 73. Okay? Now, let's say we wanted a slightly different question. Let's say we wanted to ask the question, well, let's do the reverse kind of question. So in this question, we got the z-score from the information we were given, and then we worked our way towards a percentage. Let's do a problem that goes in the reverse way, a problem that we start with the percentage, and we ask what z-score that should be. Okay? So let's do one like that. So here's a similar problem. So everything else, we'll leave the setup the same, but we'll ask ourselves to find, let's say, the 10th percentile. Okay, so the 10th percentile is the point on the curve where basically 10% of the data lies below it and 90% of the data lies above it. That's what the 10th percentile means. All right? So what that means from our perspective is now we're getting percentage information, and we need to go to a z-score and then to an actual test score. All right? So that's what we're going to do. So first of all, let's find out what z-score. And in order to do that, we need to make a symmetrical picture here. So the symmetrical version of this is that you'd have 10% on either side, right? So you've got 80% in the middle there. Okay? So in other words, we're looking for the z-score that corresponds to 80% in our table. So I'm going to go to the table now and look for that. You should do that too. You do that. In fact, if you don't have your book, you should grab it now, turn off this video, pause it, and grab it, and come back when you've found what you think the 80th percentile, what z-score corresponds to an area of 80%. Okay, I'm assuming you've done that by now. So I'm going to go find it for myself. So I go to the table and I see in the first sort of set of 3 rows, down about, well, almost towards the bottom of the page, there's the number 80.64, and that's the one I'm interested in. That tells me that, now it's not 80, so it tells me that about 80% should be about between 1.25 and 1.3 of a Z-score. I happen to know it's probably pretty close to 1.28. So if you said 1.3, that's fine. I'm going to use 1.28 just because I think that's a little closer. Although that's just from my memory, and but it's a reasonable approximation. So then we have to find out what score that corresponds to. So this is how many standard deviations above the mean we are. So the amount of test points we are above the mean will be the standard deviation times that. So we'll take 20 times 1.28, and that'll give us the number of test scores we are, of test points we are above the mean, and then we'll add that to our mean of 60. So here's another really important process. We're taking basically the Z-score, we're multiplying it by the standard deviation, and adding it to the mean. That's a really important thing. So that's what we've done. So let's see, what does that work out to? That works out to 25.6. So that the test score that would be the 10th percent. Oh, except I'm lying to you. I'm sorry. Because that would be the 90th percentile that I'm figuring out right now. Because I'm making it higher than the mean, right? So actually, to get the 10th percentile, I should have been subtracting. So I'm going to take 60 minus 25.6, which is that product there. And so 60 minus 25 is 35. So 60 minus 25.6 is 34.4. So what does that mean? That means that 10% of the students scored below 34.4, and 90% of them scored above that. Okay, so that's our answer for what the 10th percentile is. Okay? All right. Well, that's all I'm going to do for now on computing, on working with this normal distributions. If you have more questions about it, you can certainly ask me or post them in our discussion area. And if there's anything that needs clearing up, where another YouTube video could help, I'll be happy to do that. I should be posting shortly after this. I want to do one on histograms, so I'll probably do that as well. And if you need a topic, if you'd like a lecture on a topic, you could request one too. Okay, thanks. Bye-bye.